So let's go on to the solution of problem 413. So in part A in problem 413, we're asked to write up the claim B of n in terms of the two stochastic variables tx and ty. So what we see is that the benefit at time n is equal to 1 if x is dead and y is alive. So if x dies before time n, and y is alive, so if y survives past time n. And we also see that this benefit is 0 otherwise. So this means that the benefit at time n can be given as the indicator function of tx being smaller than equal to n and ty being greater than n. So that was A. Pretty simple, right? So now we go on to B. In B, we're asked, what is the expected present value at time 0 of this claim? So what is the expected present value of B of n at time 0? And as we mentioned earlier, what we actually do is we want to find the mean value, so the expected value of the present value of B of n at time 0. And if we take B of n, then we can find its time 0 value by discounting it back to time 0 in time steps, right? So this is the expected present value of B of n. What we also see is this thing is not stochastic. And as we remember pretty well by now, we can take a deterministic constant outside of the expected value. Then what we are left with is the mean value of B of n. So in part A, we figured out an expression for this claim at time n, which was that this is the indicator function for x dying before n and y dying after n. So what we have is the mean value of the indicator function for tx being smaller than equal to n and ty being greater than n. Now we recall that the mean value of an indicator function of some event is equal to the probability of said event. So this is equal to the probability of tx being smaller than equal to n and ty being greater than n. So how do we move on from here? Well, now we have to kind of go back to our assumptions, and probably we have something that we can use. And it's very nice of them because they actually tell this to us with 3 exclamation marks. So it's really like, don't forget this. So the lifetimes of the two spouses are independent. Actually, what should be written here is that the remaining lifetimes of the two spouses are independent. So tx and ty are assumed to be independent, which also means that this probability can be split up into the product of the marginal probabilities. So a joint probability for tx and ty can be split up as the product of probabilities as such. And this is written up pretty easily because what we have here is just the conditional probability of death for an x-year-old within the next n years, and that has the symbol NQX. So if this is a bit rusty, go back and take a look at chapter 3. Then you will, just freshen up these symbols again. And what we have here is the probability that the remaining lifetime of person Y is greater than N, and that is the conditional probability of survival for a Y-year-old, so survival for a Y-year-old past the next in years. And well, that's actually more or less the end of this story, except if you want to just do a little extra, because the little extra comes here. Can you recognize the product of this and this? So this is actually the expected present value of a pure endowment, can't remember if it's NEX or XEN, I think it's NEX. So of a pure endowment that an X-year-old buys, which ends in N years. And the reason why that is so, if you just recall how the pure endowment works, you stand at time 0, and if you're alive at time n, you get 1 unit at time n. Hence, the expected present value of such a contract is equal to the probability of surviving until then, multiplied by 1, and then discounted back till now, which is why we have the discount factor. So the expected present value of this contract that we have with the two spouses is given as such. You take a pure endowment, and then you say, well, it only comes into play. Oh, sorry, this should be a y, right? Because we're looking at the y-year-old here. So you take a pure endowment, and you say, well, it comes into play when y survives past time n, and x dies before time n. So that is the EPV of the expected present value of this benefit contract. So for C, take a look at the next video. It will get its own video because we will need to use the equivalence principle, and that is actually the first time we use it. So it kind of deserves its own video. So take a look at the next one for the solution of C.